Good morning to everyone. Today we are here to discuss about on the topic of image generation using GANs, creating artificial faces with style GAN. This is Nandakishore Reddy and my teammate P. Rajshekhar. We are done and are supervised by Sarandra sir. Coming to the content, here we can see the introduction, objective of the project, literature review, proposed system, methodology, algorithm and description, implementation, testing and validation, results and analysis, sustainable development goals, challenges, advantages, limitations, and future scope, conclusion, references. Coming to the introduction of the project, GANs, General Adversarial Networks, have emerged as a groundbreaking deep learning framework for generating synthetic data, particularly images, developed by Ian Goodfellow and his team in 2014. GANs consist of two neural networks, a generator and a discriminator, that are trained simultaneously in a game theoretic setup. The generator attempts to create realistic data, while the discriminator evaluates authenticity of the data. The realism and flexibility of StyleGAN generated faces have opened new possibilities in fields such as virtual reality, gaming, cinematic production, facial recognition research, and privacy preventing datasets. The main objective of the project is to generate synthetic image generation with a focus on generation lifelike human faces. The project aim is to thoroughly explore the architecture and functioning of GANs, with special emphasis on StyleGAN, a state of the art model developed by NVDIA. The key objective is to gain deep understanding of style-based generation approach, where image features can be controlled at different level of details, from coarse attributes like face shape and gender to fine-grained details such as skin texture, lighting, and hairstyle. Another main aim is to evaluate the practical application of artificial face generation, such as creating synthetic datasets for training facial recognition system, preserving user privacy by replacing real images with synthetic counterparts, enhancing creative process in media. These are the literature review. We have taken 10 literature reviews. Coming to the proposed system, the proposed system of StyleGAN architecture, a leading model in generative adversarial network. This system is built with harness the strengths of StyleGAN 2 or StyleGAN 3, which provides superior image quality, better latent space, and improved future controls compared to earlier GAN models. The architecture consists of two primary neural networks, the generator and discriminator. This is the methodology or architecture diagram of StyleGAN 3. The previous diagram illustrates the architecture of StyleGAN 3, which is an advanced generative model used to create quality images specifically designed for tasks such as face generation. Here are the breakdown of components shown in the diagram, which are input latent space, mapping network, style modulation, alias free synthetic network, generated image, discriminator, loss function, and training. This is the algorithm for the StyleGAN 3, and the below points are description for the given expression. Implementation. In implementation, there are 4 steps: environment setup, dataset preparation, training StyleGAN 3 model, generating AI faces. To begin, ensure that we have the necessary hardware and software requirements. The hardware requirements for the project is NVIDIA GPU, preferably RTX 3090, 100 or higher, at least 24 GB VRAM, CUDA 11 and CUDA-NN for GPU acceleration, minimum 100 GB of storage for datasets and model checkpoint. For data preparation, before training, we need a dataset of images in a supported format. Example like 1024 into 1024 or 512 cross 512. For generating AI faces, we should generate random AI generated images using trained weights, Python generated .py, pkl seeds. With the help of seeds, we can generate the output images. Coming to the testing and validation, the testing methodology for StyleGAN 3 involves multiple evaluation techniques to ensure high quality realistic image generation. First, visual inspection is conducted to check for artifacts, consistency and diversity in generated image. Next, quantitative metrics such as Frechet inspection distance, kernel inception distance, and precision recall scores are calculated to assess image quality and diversity. The combined approach ensures that StyleGAN 3 produce high quality, diverse and stable AI generated image. These are the validation metrics. Accuracy is 90%, precision is 80 to 90%, recall is 70 to 85%. Results and analysis. StyleGAN 3 developed by NVIDIA improves upon its predecessors by addressing analyzing issues and enhancing image quality. It achieves state-of-the-art result in generative adversarial network with superior consistency in fine detail. StyleGAN 3 performance makes it ideal for high quality image generation tasks in AI art, deepfake detection and synthetic data application. Coming to the sustainable development goals, the project contributes meaningfully to multiple sustainable development goals by advancing technology while addressing ethical, educational, and privacy concerns. By focusing on artificial face generation using StyleGAN, the project strongly aligns with SDG 9, which includes industry innovation and infrastructure, and also supports SDG 4, which includes quality education by enabling the creation of large scale, diverse, and privacy preserving datasets for training AI modules, which are crucial for education and research. Further, the project addresses SDG 16, which includes peace, justice, and strong institutions by emphasizing ethical AI development and responsible use of synthetic media, and also indirectly support SDG 3, which includes good health and well-being, particularly in healthcare research when patient identity protection is critical. Additionally, the project force intuitively by enabling the generation of diverse facial image that represent different ages, genders, contributing to SDG 10 reduce inequalities. These are the sustainable development goals. Coming to the challenges encountered, we have encountered some challenges like high computational requirements, training stability issues, mode collapse and diversity loss, longer training time compared to StyleGAN 2. Advantages of our product are high quality and realistic image generation. This project uses StyleGAN which develop high quality and realistic image, and it improves privacy protection data augmentation for machine learning, control and customization. It supports ethical AI development. It promotes innovation and research. These are the advantages of our project. Coming to the limitations and for the future scope, the limitations are computational resource requirement, risk of misuse, ethical and legal concern. These are some limitations of our project. And coming to future scope, the future scope of this project is vast with multiple opportunities for advancement and application across various fields. One significant direction is the optimization of style GAN model to make them more lightweight and efficient, allowing real-time face generation even on mobile devices and web platforms. Further research can also focus on mitigating biases by using diverse and representative training datasets, thereby ensuring fairness and inclusivity in generated outputs. Coming to the conclusion, the project has successfully explored and demonstrated the immense potential of generative adversarial network in the field of synthetic data. By utilizing the advanced architecture of StyleGAN, the project has been able to generate high realistic and diverse artificial faces that are visually indistinguishable from real human images. However, this project also acknowledged the challenges and responsibilities associated with generative technologies, including concern about data bias, high computational costs, and risk of misuse in creating deepfake or spreading misinformation. These limitations calls for continued research into bias mitigation. It also stands as a meaningful contribution to the field of artificial intelligence, promoting both technological progress and responsible innovation. This is the YouTube link and GitHub link. These are the publication status. We have published our conference paper in ICITSM. These are the certificates which we got after the presentation of in IEEE. These are the references where we followed these references about style GANs and we had made this project.